Hello, sixth graders. Welcome to sixth grade math mean absolute deviation lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is I can find the mean absolute deviation of a data set by completing practice problems with 100% accuracy in multiple attempts. The standard we'll be working on today is summarize numerical data sets in relation to their context by finding measures of center, variability, and overall patterns. Let's start with today's key idea. It starts with a little vocabulary review. Another measure of variation is the mean absolute deviation. The mean absolute deviation is an average of how much data values differ from the mean. So it's important in your notes to be sure and have that definition and also have the steps to finding the mean absolute deviation. And that's kind of a mouthful, so we usually just call it the MAD or the MAD. Step 1, we just find the mean of the data. And step 2, we find the distance between each data value and the mean. So that means you need to subtract each data value from the mean and find out how far away that is. So you need to think of it as a distance. So just like absolute value, it always has to be positive. So it's a distance and it's always positive. And step 3, you find the sum of the distances in step 2, so you add all of those up, and then you divide the sum in step 3 by the total number of data values so you're finding the mean of that, just like you found the mean of your original data set. Let's take a look at example 1. We're finding the mean absolute deviation. It says you record the numbers of raisins in 8 scoops of cereal. Find and interpret the mean absolute deviation of the data. So again, there's that word interpret. So that means you need to explain what your mean absolute deviation means. So here's our data, and it's already in order for us, which is helpful. So step 1, we find the mean. And that calculation is there, and it turns out to be 3. And step 2, it says you can use a dot plot to organize the data and replace each dot with its distance from the mean. And another way to do it is to just simply subtract. So if you look at each data value, you can say, well, 3 minus 1 is 2, and 3 minus 2 is 1, and 3 minus 2 is 1 again. And 3 minus 2 is 1 again. So there are 3 2's, so that means we have 3 values of 1. And 4 minus 3, so I turn that around, is 1. 4 minus 3 again is 1, and again is 1. And 5 minus 3 is 2. So I did the same thing without a dot plot. So if you don't want to do a dot plot, you don't have to. You just need to subtract. And then the sum of those distances, so we add all of those up and we get 10. And then you take that sum and you divide that by the number of numbers you had, so that would be 8, and that equals 1.25 in this instance. So the data values differ from the mean by an average of 1.25 raisins. So this is your interpretation. This is your MAD, 1.25. Here's another example, example 2, and in your notebook it's split into 2 slides, 2A and 2B. So it's a real-life application. The smartphones show the numbers of runs allowed by 2 pitchers in their last 10 starts. So you can see the pitchers over here. There's Mendoza and Rodriguez. And we're going to find the mean and the median and the MAD of the numbers of runs for each picture. So we need to do that for both of those pictures. So in your notebook, I start with the median because we need the mean for the MAD. So it's easier to do the median first because we don't need that for the MAD. So the median for Mendoza is right here. We put the numbers in order, and we have two middle numbers. They're both 4, so our median is 4. And then we find the mean for Mendoza, and it's 3.5. And then the mean absolute deviation. So we take each one of these runs and we subtract it from the mean. So that's shown here for you on the dot plot. And then we divide that by the number of data, pieces of data that we had, which is 10. So it's 24 divided by 10, so that equals 2.4. And then we do the same thing for Rodriguez. Rodriguez's median is also 4. And his mean is also 3.5. And then we take a look at his runs and we subtract all of those from 3.5, and we look at the distance from the mean for him, and we divide that by 10. We add those up, and we get 14 divided by 10, which equals 1.4. So his MAD, Mendoza's MAD, is 2.4, and Rodriguez's MAD is 1.4. Now when you look at part B, it asks you which measure can you use to distinguish the data, which means you need to find a difference between their two sets of data. So it says, what can you conclude about the pictures from this measure? So we can't use the measures of center. So remember, our measures of center are median and mean. We can't use those to distinguish the data because they're the same. So if they're the same, you can't tell what the difference in the pictures is. The measure of variation, MAD, is 2.4 for Mendoza and 1.4 for Rodriguez. This indicates that the data for Rodriguez has less variation. So using the MAD to distinguish the data, you can conclude that Rodriguez is more consistent than Mendoza. Remember, you need to complete your notes in your ISN, complete your Google Form questions, and review your lesson if you need to. Also, complete your Big Ideas math assignment in your Math Spiral notebook and submit that when it is 100% correct and not before. Be sure you track your progress on your playlist.